Alright, so this is a free fall problem, and we're going to try to do this with very limited equations, meaning all the equations I have here are mainly definitions. None of them are what I call magic equations, where you don't really understand what's going on. You just get an answer. So the first equation is that the average velocity is equal to the change in position over the change in time. That should make sense, how far the average speed is. How far do you travel over how much time gives you your average velocity? That's something that we should hopefully be able to wrap our heads around. Next is acceleration. Acceleration is just how much the velocity changes over how much time it takes. And the last one's probably the easiest, the other average velocity. It's just the average of your starting and final velocities. So average them, meaning adding them up, divide by 2. So that's all we're using for equations. Here are 6 variables that we have. They pretty much come into play in any problem. So here we have a situation where we're dropping a rock off a cliff. So I'm up on my cliff, I'm dropping my rock. And if I do that, I know that if I'm dropping it, my initial velocity is 0 because I'm not throwing it, it's not moving when I let go of it. The question is, I don't know how fast it's going at the final speed, and the final position we're saying is 2.5 seconds later. So it may not actually be, you could have time before or after that. Final is sort of arbitrary. It's whatever you want it to be. But anyway, that's our time, and we want to know how high is the cliff. So we're really looking for this delta x value. The question is, how are we going to find that? So basically the way we approach this, if we look at the equation, we say this is the only one that has delta x in it, so we're somehow going to have to use this equation. And to do this, we're going to have to find out the average velocity. Finding out the average velocity is typically something we're going to need to do. The only way you can find out the average velocity is to know the starting and final velocities. And we know the starting velocity already is 0. So now we want to find the final velocity. So one way to think about this is we need to know the acceleration. And since we're on Earth, we're going to assume it's 10 meters per second squared. What that means is that the velocity changes by 10 meters per second. So every second it's in the air, the velocity changes by 10. So in this situation, if I made a chart of time versus velocity, when I let go of it at time 0, the velocity was 0 meters per second. 1 second later, it's going 10. At 2 seconds, it's going 20. At 3 seconds, it would be going 30. However, we're not going to 3 seconds, we're going to 2.5. So at 2.5 seconds, it's going to be going 25 meters per second. So at this point, the final velocity is 25 meters per second. So it starts at 0, it finishes at 25. And that's sort of just assuming no air resistance or anything like that. So knowing that, I should be able to find the average. It's just the average of 0 and 25, which is 12.5. So the average velocity is 12.5 meters per second, and it's falling for 2.5 seconds. So if I want to use an equation, I can now use this equation, which says the average speed is 12.5, and we do not know how far it's traveling, but we know it travels for 2.5 seconds. So now we just solve for x, so I could cross-multiply if I want to do it that way, however you want to do it algebraically. But we find that x equals 12.5 times 2.5, which is simply 31.25 meters. So this thing falls 31.25 meters in 2.5 seconds. So we tried not to use too many equations. You certainly can use these ones. But hopefully the understanding is there, that this thing was moving 0, it started moving 25, so the average is 12.5, and we can assume that average speed over the entire time is the idea of the average. So anyway, until next time, I am Derek Genova. Have a delightful day.